Hello, everybody. Today we will be solving problem 1 of the 2006 IMO. The problem reads, let ABC be a triangle with incenter I. A point P in the interior of the triangle satisfies angle PBA plus angle PCA is equal to angle PBC plus angle PCB. Show that AP is greater than or equal to AI and that equality holds if and only if P equals I. Okay, before I go ahead and dive into the problem, I am going to show a very important lemma. It's called the Incenter-Excenter Lemma. It's also called fact 5, is that written here? And I've also drawn out a diagram for this lemma. And basically what this lemma says is that if you've got a triangle ABC and the incenter is I, and then you have this excenter IA, then the points B, I, C, and IA lie on a circle. This circle has center L, where L is the point, where L is a point on the circumcircle of ABC. And A, I, L, and IA are all on one line. So this is the Incenter-Excenter Lemma, and it's going to be the very critical lemma that we use to solve this problem. Okay, so keep that in the back of your mind. Okay, so I'm going to clear all this. And one other thing I am going to do before I actually go and look at this problem is I'm going to draw out a triangle over here. And we are going to have its incenter be I. We're also going to call this triangle ABC because ABC is a common name for a triangle, basically. And I'm going to actually find this angle BIC. And this is going to hold for any triangle. We're going to find this angle. And remember, the incenter is the intersection of the angle bisectors, which means that this angle over here is going to be equal to this angle over here. This angle over here is going to be equal to this angle over here. Right? And we can also draw this line, but it doesn't matter. We're going to call these angles A, B, and C be the angles of this triangle at vertices A, B, and C, right? So A plus B plus C is 180. Or we could write this as A over 2 plus B over 2 plus C over 2 equals to 90. Or we could rearrange this as A over 2 plus 90 equals 180 minus B over 2 minus C over 2. We just moved B over 2 and C over 2 over to this side and added 90 to both sides, right? But notice this angle is half of angle ABC, so this is B over 2. This angle over here is C over 2. So angle BIC is 180 minus B over 2 minus C over 2. So it's A over 2 plus 90. Also keep this in mind. Right, now I'm just going to clear all this. Now I'm actually going to go draw the diagram that we will be using to solve this problem. That is, we have a triangle ABC. Its incenter I should be somewhere over here. And we have a point P over here. And P is such that angle PBA plus angle PCA is equal to angle PBC plus angle PCB. So if I color this angle red and I color this angle red, then I color this angle orange, I color this angle orange, I'm going to get the sum of the red angles is equal to the sum of the orange angles. So I can write this as sum of red angles equals the sum of orange angles. And notice that the sum of the red angles plus the sum of the orange angles is angle B plus angle C. So you can write this as the sum of the red angles plus the sum of the orange angles is equal to B plus C, angle B plus angle C. This angle plus this angle. Right, so we can substitute red with orange, and we get 2 times the sum of the orange angles equals B plus C. So the sum of the orange is B over 2 plus C over 2. So angle BPC is 180 minus that. Which you'll recall from a bit earlier is equal to 90 plus A over 2. But notice that that just happened to be what angle BIC was. So in other words, we have this angle over here. And I can write this as this, this angle over here is equal to this angle over here. And since they both enclose this arc BC, we get that BPIC is actually cyclic. So I am going to draw the best circle I can that encloses these 4 points. Right. And we're going to call the center of the circle. Do it a bit over here. We're going to call the center of the circle L. And by now, I think you can see where we're going. We're going to use the Incenter-Excenter Lemma. And what we've got from that lemma is that A, I, and L are collinear. Right? Because that was the second part of the Incenter-Excenter Lemma. Right. So then what I do is I draw LP and I draw AP. And simple triangle inequality gives AP plus PL is greater than or equal to AL. But remember, AL can be broken up into AI and IL. So I can write this as AI plus IL. And equality holds when P is on the segment AL. Right, but since L is the center of the circle and both P and I are on this circle, we can cancel out this and that. PL is equal to IL since they're both radii of this circle. So we get AP is greater than or equal to AL. And the equality holds when P is on this circle. I mean, not the circle, when P is on AL, but since LI is equal to LP, if P is on AL, we also have that P is on the circle. So P would actually be the intersection of AL and circle L. So P is equal to circle L intersect AL, which would be equal to I. Notice it wouldn't be equal to IA, which is the other intersection point, because then we wouldn't really have a triangle like that. So if P is the intersection of circle L with AL, P is I. And conversely, if P is equal to I, then AP plus PL is AL, in which case equality holds. So that proves the if and only if statement. Otherwise, AP is greater than or equal to AL, which was what we wanted. So we are done. Thanks for watching, and I will see you next time.